Hello, everybody. Good afternoon. My name is Jingyue Li. I'm a professor at the Department of Computer Science, Norwegian University of Science and Technology. Today, I'm going to present a paper titled Systematic Literature Review on Client Selection in Federated Learning. The paper is authored by Carl Smackstad, who was one of my master students. This is outline of the talk. Federated learning was proposed in 2017. The idea of federated learning is to let a server to coordinate the training of a global model with several clients. The clients can be mobile devices, pad, and edge devices. The devices will host local data and train the model together with other clients coordinated by the server. There are two reasons that lead to the idea of federated learning. One is big data and edge computing trend. In the last few years, the computational power and memory and internet speed of the mobile pads and edge devices increased a lot. Then it makes it feasible to use those edge devices to train a model, to host some data, and to communicate with the server in a fast speed. Another reason is the need for privacy preserving deep learning. In some application domains like healthcare, people don't like to transfer patient data to the server due to the privacy concerns. Therefore, a better idea is to host the privacy critical data on the client and then run the model training on the client and share the trained model, which is probably is not that privacy critical any longer to the server. Federated learning has a lot of challenges like efficient communication, heterogeneous systems, statistical heterogeneity of data, and privacy concerns and privacy preserving methods. Among those challenges, another critical issue is the client selection strategy. A good or bad collection strategy can bring positive or negative impacts on different aspects of federated learning. For example, if you choose all clients without considering their computation power, their internet speed, then you may have a lot of heterogeneous clients in the model training, and the training speed could be low and the model could be in bad quality. If you randomly choose the clients, the chosen clients may not be the optimal ones. That can also harm the efficiency and effectiveness of the model training. So people have proposed a lot of client selection strategies to try to propose or identify the best clients in the training. Our research is motivated to summarize how studies have tried to improve client selection, as many problems can be addressed by better strategies than random selection. With this motivation, we try to answer 4 research questions. We want to summarize what challenges are being addressed by the state-of-the-art strategies. We want to know what solutions have been proposed to address those challenges, what metrics have been used to measure the success of the proposed solutions, and what future work have been identified by the state-of-the-art studies. Our study followed the guideline proposed by Wulin. We started with literature search, but we found that using the keyword-based search can return a lot of irrelevant papers. Then we decided to start with a set of papers that are in good quality and that are definitely relevant. Based on the start set of the papers, we do backward and forward snowballing to identify more relevant papers. Then we do filtering to try to exclude the ones that are not relevant, and we do the filtering based on inclusion and exclusion criteria, and also we assessed the quality of the paper to include only those ones with good enough quality. We used the well-known and popular quality assessment criteria to evaluate the quality of the chosen papers. So we want to make sure that all the chosen papers give sufficient information about their motivation, the research design, and the methodology is a rigor. After that, we analyze the data using semantic analysis. So, as I mentioned, we start from a set of paper. We start from 6 papers. The papers are listed in our publication, so I will not go through each of it. After snowballing, filtering, and quality assessment, we end up with 47 primary studies for data analysis and synthesis. Now I will give a brief summary of the answers to each research question. For the research question 1, we categorize the challenges focused by the primary studies into 4 classes, like heterogeneity, resource allocation, communication cost, and fairness. Here I will go a little bit in depth of each challenge. For heterogeneity, a critical challenge to address is the inefficient trained model performance and accuracy degradation caused by the heterogeneous systems and data. And also increased biases and unnecessary exchange of information is to be addressed, because that is also a problem caused by heterogeneity. Regarding resource allocation, a critical challenge is that large models are energy consuming and difficult for clients with low computational resources to address. With respect to communication costs, clients with low power or slow will lead to long converge time. That will increase the communication costs, and the long distances between clients and servers will also be a problem. For fairness, selecting only the fast clients, of course, will increase the training speed, but that will exclude those slower ones which are willing to participate. That leads to unfairness. Unfairness can further lead to heavy biases as some portions of the data are neutralized. People have proposed a lot of solutions for each challenge. We have made a complete list here, and we have explained the solutions in the paper in detail. Here I will only give one example to address the heterogeneity challenge. One solution is to select subset of clients to make a homogeneous dataset, meaning the datasets are homogeneous, and you can do a training within the cluster, and then do a further training based on the intermediate results. People have proposed a few metrics to measure the success of the proposed solutions. The most used metric is testing accuracy versus communication wrongs. To measure the solution for heterogeneity, the number of select clients able to finish training is also measured. To measure resource allocation solutions, in addition to testing accuracy versus communication wrongs, the energy delay and the client consumptions are also measured. People also measure cost of hiring clients as part of the communication cost, because that is related to the totality of the training cost. To measure fairness, availability of clients and the long-term fairness constraints are also important data to collect to make sure that you provide fair training, but you do not harm the low-speed clients. The primary studies have also identified a few research directions. For example, optimal threads for splitting clusters of clients. And also, people should propose better approaches to address the effect of unsuccessful clients or free riders and their quality impact. The idea of federated learning is to reward those clients with significant contribution and punish those free riders. But the current solutions are still not good to address this question. To address communication costs, a possible research direction is to have a better incentive mechanisms to encourage more computing power, so that each client is a lot more powerful than today, and that can possibly reduce the unnecessary communications between clients and servers. Of course, trade-off between fairness and training accuracy is critical to deal with the fairness issues in the federated learning. Besides those research items and limitations identified by the primary studies, we have also found several interesting topics based on our cross-paper analysis. We found very few studies compare different client selection strategies from the third-party point of view, meaning that very people have tried to replicate the existing studies to verify their conclusions. This can be done better in the future. Many papers have mentioned fairness, but very studies have really proposed solutions to deal with that. So this is an underexploited domain. Most studies try to optimize the input to the federated learning algorithms, for example, to give optimized and homogeneous data, or to provide faster clients. But we believe that it will also be beneficial to have more flexible and agile federated learning algorithms. We hope to see resource awarded and domain customizable federated learning so that the learning algorithms can be adapted automatically according to different inputs. In summary, our study recognized that federated learning is beneficial for the society and the industry, and the client selection strategy is critical for the success of federated learning. We have tried to summarize the challenges addressed by existing studies, the solutions they have proposed, the metrics they have used, and the future work they have identified. In addition, we bring several insights to inspire researchers to do future work in this domain. These are the references related to this talk. Yes, now I'm open for questions and comments, and thanks for your attention.